USB is nearly everywhere. When you see a port that looks like this on the back of a computer, regardless of the color, that's a USB port. One of the bummers about all of these USB connectors is that if you try to plug them in upside down, they won't work. This is why the newest version of USB, called USB-C, is a very welcome change. It's reversible, so it doesn't matter which way you plug it in. Another significant port on the back of a computer is the Ethernet port. The Ethernet port allows you to plug in an Ethernet cable, which can connect your computer to a network and to the internet. For many years, the 15-pin VGA port was the standard, and next is the Dvi port, which comes in a few different variations. By far the most common connector for connecting a display, whether it's a computer monitor or a widescreen TV, is an HDMI port. HDMI is fully digital, and it supports. The final video connector we'll look at is called Displayport. Displayport comes in two sizes, and if you're a Mac user, you'll probably recognize the smaller of the two, called Mini Displayport. Speaking of Macs, it's worth noting that the Mini Displayport on newer Macs is also a Thunderbolt port, which is indicated by the little lightning bolt symbol. Turning to audio, we've got our standard 3.5mm headphone jack and a 3.5mm audio input jack.
A USB port, cables, and connectors. Now USB stands for Universal Serial Bus. The USB is the standard that is used to connect peripherals to a computer, and it's by far the most commonly used port. And the reason why it's so commonly used is because, just like its name says, it's universal. The USB port is used to connect many different kinds of devices, such as keyboards, mice, cameras, printers, scanners, external hard drives, flash drives, and they can even do networking and so much more. And it's also used to charge devices such as cell phones. And desktops and laptops will have several USB ports. Now the goal of the development of the USB was to make connecting devices to a computer much easier. And this is done by first making one standard connector, therefore eliminating all the other different kinds of connectors. And second, by making connected devices easier to configure, and third, to provide fast transfer rates. The USB port is also hot swappable, so devices can be connected or disconnected without turning off the computer or the device. The USB also self-configures itself, which eliminates the need for any extensive configuration or no configuration at all. And in addition to connecting to a computer, certain smaller devices can be powered by the USB port without the need for additional power cables. The first USB version was released in 1996, starting with USB 1.0, with later versions released throughout the years. Now USB 1.0 had a transfer speed of 1.5 megabits per second. In 2008, USB 3.0 was released, and this was known as Super Speed USB. USB 3.0 boasts speeds of 5 gigabits per second. The high-speed increase was meant for transferring large amounts of data, such as backing up to external hard drives. Now, USB 3.1, which was released in 2013, and this is also known as Super Speed Plus. USB 3.1 had a transfer rate of 10 gigabits per second, which is double of USB 3.0. Then soon after, USB 3.2 was released, which had a transfer rate of 20 gigabits per second. And in 2019, USB 4 was announced, and this has a transfer rate of 40 gigabits per second. Now USB cables will typically have two different connectors on each end of a cable. They will have either Type A, Type B, or Type C, with the Type A connector on one end and B and C type connectors on the other end. Now the Type A connector is the host connector. This is a standard rectangular plug that you would plug into a computer, and computers will have several Type A USB ports. And even though this is the oldest connector type, it is still being used today. Type B connector is a square design with beveled corners on top. Now this is also an older connector, but it's still being used today. This type of connector is what you would plug into most printers today. But it's also used on other devices, such as external hard drives, USB microphones, and so on. Also the USB 3.0 Micro B, And this connector is just as thin as the 2.0 version, but it's wider. It's basically a USB 2.0 micro B connector, but with 5 additional pins that are stacked on the side of the connector, which doubles the width of a 2.0 micro B. This connector is used to carry data and supply power to devices, such as modern external hard drives. And in 2014, USB-C was developed, and it was developed with the USB 3.1 standard. Now this is a thin connector with rounded edges, and it has 24 pins. And it easily plugs into a port because it doesn't have an up and down orientation. Today, the USB-C can be found on modern smartphones, external hard drives, tablets, and modern desktop and laptop computers. Now USB 1.0 and 1.1 ports will have a white color. Now these ports are old, slow, and outdated, and you won't find them on modern motherboards anymore. USB 2.0 ports will have a black color, and even though they came out in the year 2000, you will still find them on motherboards today. USB 3.0 ports will have a blue color, USB 3.1 will have a teal color, and USB 3.2 ports are red. Now there are also ports that are called sleep and charge ports, and this means that they will still supply power even if the computer goes into sleep mode, which means you can continually charge a device such as a cell phone even if the computer goes to sleep, which is convenient. And these ports is called HDMI, which stands for a High Definition Multimedia Interface. HDMI has a broad range of use in electronic products such as TVs, monitors, laptops, mobile devices, and so on. It is in fact the dominant video port that is used today. It was developed in 2002, and it was designed for transmitting uncompressed video and audio digital data through a single cable. HDMI is one of the best standards for high definition in consumer electronics, delivering crystal clear video as well as audio. But in 2009, HDMI 1.4 was released, and it added another channel to HDMI for data, which has the capability of network communication. So the connected devices that use this feature will give HDMI the ability to send and receive data at 100 megabits per second Ethernet. So in addition to video and audio on a single cable, the HDMI cable will have another ability of Ethernet networking. But also with HDMI 1.4, it also added support for 4K video at 30 Hz. And in 2017, HDMI 2.1 was released, which added support for higher resolution and refresh rates, with support for 4K video at 120 Hz and 8K video at 60 Hz. And it can also support a max resolution of 10K for commercial audiovisual systems and specialty usages. There's fiber internet. Fiber offers the fastest internet speeds available today. It has download and upload speeds of 1,000 megabits per second, so it's very fast. And the reason why it's so fast is because it uses light to send data running through fiber optic cable. And fiber optic cable is what's already used as the backbone of the internet. And in addition to the benefit of the faster speed, fiber can also travel much longer distances than DSL or cable. And this is because DSL and cable transmit data using electricity over copper cable, and signals in a copper cable can be affected by electromagnetic interference as it travels, which can weaken the signal, especially over a long distance. But fiber uses light to transmit its data, and it transmits it over a thin glass cable, which makes it less vulnerable to interference. So as you might have guessed, fiber is more expensive than DSL or cable, and fiber is relatively new compared to DSL or cable. The infrastructure is not there yet, so fiber may not be available in many locations.
those go to the O drive. Yep, that's the same down the bottom. So we've got the encoder on the back of the motor with an encoder cable that I've made the right length that goes to the O drive, and the power leads come out the bottom to the bottom of the motors. So the main control system for the robot is a Teensy 3.6, and I've got this on Perma Proto board, which is made by Adafruit, and that's basically a breadboard solder board, so it's really easy for prototyping, especially for dual inline packages. So there's lots of PWM's ins and outs here, which will be for reading. Obviously we've got the breakout again here, we've got the motor encoders that'll be plugged in there, and the wires that come back to these motor drivers, and so we'll wire everything to this board and strain relieve it on here with zip ties. Well, that's quite a lot worse looking now all of these wires are on. Obviously we've got these wires here that take the encoder signals and bring up the PWM signals for those motor drivers to drive the motors, and those all go to this connector that goes to our box with the Teensy in. So this wiring's a bit messy. We have got motor power coming from each of the motor drivers and going to the motor drivers from our main power wire. So ideally we'd make a custom PCB in the future with proper screw terminals, or PCB mounted XT60s or something to bring the power box with our Teensy in, and that's got two connectors. One is all the O drive serials, ground and reset pins, and the other one is all the PWMs and encoder signals for the motor drivers at the top. So the first O drive on the way up has serial lines, a ground pin and a reset pin, and that reset pin goes down to the emergency stop, which is mounted on the box with the Teensy in. So on the way up we've got this wire here, which is some power wires for the O drives and the serial grounds and resets for the two O drives at the top. We've also got this one, which is all of those encoders here, and we've got some spiral wrap that's wrapping up the cables so they're nice and constrained, and we can still move that arm all the way around with no issues there. And the sun, they really do need sorting out because they're just hanging around. At the moment I've just soldered wires onto pin strip to make a connector, which is far from ideal. So really we need to constrain this on a PCB bin. There we go. So those are turned right down. They're far excessive of what they need to be really, but obviously pretty quick. So we can do some great dance moves. We really do need deceleration though. Of course the stand rocks because it's a bit back heavy, so that needs sorting out as well. So there we go. We can do that as well in the other position, and everything's good. Probably need to